Hey, 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 we're back here. Last section of chapter 6. That's got to be pretty exciting, right? We'll be solving systems of inequalities in this last section, which, as long as you know how to graph a line, is not too difficult. Okay? The reason we have to graph inequalities and can't use them by any other way is because they have an unlimited number of solutions. So graphing is the only way that we can go about showing those solutions. Okay? So the only difference between graphing equations and inequalities, remember back, this was 2 chapters ago, I believe, is we have to check to see if it's a solid or a dotted line, and then, oops, dotted. And we also have to do the shading, where we have to pick a point and shade on one side or the other. Okay? So, just like how we had to solve systems of equations by looking at where the lines intersect, let me scroll down there, where they intersect, to solve systems of inequalities, we look at where the shading intersects. Remember in section 1, we just circled where those 2 lines intersected, and that's where our solution was. If they didn't intersect, there was no solution. Or if they were the same line, it was infinite solutions. The same kind of things are going to happen here with inequalities, except we're going to look at what happens to the shading, not just the lines. Okay? So let's take a look at our first example. Again, we need to make sure that they're in slope-intercept form. These 2 are, so I can go ahead and make my graph. Okay? Y is less than negative x plus 1, so I'll go up 1. And let's try to color code these a little bit. So we're going to do this one in green, and we'll do the bottom one in red. Okay? So I'm going to go up 1. Then it's going to tell me to go down 1 and right 1 for my slope. Now, solid or dotted line, we see there's no equal to sign, so it's a dotted line. Okay? And now what's going to happen is we're going to check the shading. So we need to pick a point. We can pick 0, 0. 0 is less than or equal to the negative of 0 plus 1. Negative 1 times 0 is 0. So we're just left with 0 is less than 1, which we know is true. Now, we do not want to color in all the shading. Okay? All you need to do is make some sort of notification as to which side the shading is on. Okay? So we know it's going to be on this bottom side, so we're just going to kind of make a little hash mark or something around here so we know where the shading's at. Okay? You can put a couple of them through here. You can put smiley faces, arrows, whatever you want to do to let you know that the shading is on this bottom side. So then we take a look at the red line. Our y-intercept is up 3, so we're up 3. The slope tells me to then go up another 2 and over 1. We see that this has an equal to sign with it, so we know this is a solid line. And typically, we would see where the lines intersect, but remember we need to look at the shading. So I can, again, plug in 0, 0. So 0 is less than or equal to 2 times 0 plus 3. 0 is less than or equal to 3, which is true. So again, I'm just going to make little dots to indicate which side to shade on. I'm shading on the right side. So what you need to look at now is where the shadings intersect. And if you can imagine it, it's going to intersect and shade right here in the middle. So these are all of our solutions. Okay? That's all you need to shade in. You don't need to shade in the rest of it, just where those 2 intersect. All right? Now, do not do this part. Just put your pencil down here for a second because I want to help us out. If I were to color in all this shading, the whole green line went over here. Okay? The whole red line was on this side. You can see that where I colored in black, right here, is where the shading intersected. This was all red up top. This was all green up top. Down here is where it intersects, so that's our solution. But all you needed to have was just the black that I colored in the first time, okay? So I hope you didn't color in all that in. That's why I told you to put your pencil down. Hope you listened, okay? So let's take a look at example 2. Down in example 2, I need to solve for y first. I need my slope-intercept form for both of the equations. So if I start with x minus y is less than -1, I solve for y by subtracting x. Then I need to divide by -1, and we're dividing by a negative, so you must flip the sign and get positive x plus 1. So there's an equation. Then I have x minus y is greater than 3. Again, subtract x. Negative y is greater than negative x plus 3. Add y. Sorry, no, not add y. Whoop. Getting ahead of myself. -1 divided by -1. I'm dividing by a negative. So y is less than x minus 3. Okay. Again, we'll color code them. We'll put this one in green. We'll put this one in red. So I'm going to go up 1 and then up 1 over 1. Use a dotted line. And then check the shading. I can use 0, 0. So 0 is greater than 0 plus 1. 0 is greater than 1. That is false. I hope you got that was false. So that means we're going to be shading over here on the top half, the left half. If I do the green line, I'm going to go down 3 for my y-intercept. My slope is 1, so up 1 over 1. Color that in. It's a dotted line also. Okay. And we'll plug in 0, 0. 0 is less than 0 minus 3. 0 is less than -3, which again is false. So I'm shading away from 0, shading this way. Now, take a look at this. My green shading goes down. My red shading, sorry, my red shading goes up. They don't intersect anywhere. What do you think is going to happen if none of my shading intersects? Just like if my lines did not intersect for equations. This becomes no solutions. Excuse me. No solutions. Okay? You cannot just look at the slope to determine that. You have to graph it because you need to know where the shadings go. There will be times where this green shading might still be down, and this red shading might be going down also, in which case there will be intersection. Okay? So don't make a shortcut here. You have to graph these and shade them to know where the shading goes. So let me get that inserted in here, and I'm going to pause this real quick and grab a drink of water. Excuse me, sorry about that. Back now, so we're going to take a look at example 3. In this case, we have 3 different equations to look at. And again, we still need to have everything in slope-intercept form. The first one already is, so let's go ahead and solve the other 2 for slope-intercept form. And I'm going to solve for y, so we'll subtract 2x. I'm going to get -7y is less than or equal to -2x plus 4. Okay, now please don't freak out here. It's not going to be nearly as bad as it looks. Y becomes greater than or equal to, make sure you flip your sign, 2/7 x minus 4/7. Okay, do not freak out. We'll be okay. We'll survive. It's just a fraction. And over here I have 3x plus 2y is less than or equal to 6. Solve for y again. So minus 3x. 2y is less than or equal to negative 3x plus 6. Divide by 2. Y is less than or equal to negative 3 halves x plus 3. Okay, I color coordinated these again. And we'll go ahead and put this top equation, still inserting, put this top equation in red. Then I'll go ahead and draw the axes down here in black so we can look at all these. Okay? So we'll draw this in. Put my lines in so we can have a nice thing, or a nice graph here. Sorry about that. I had to count the lines that I needed so I knew how many. All right, now we have our graph. Let's take a look at the equations. First one, y is less than, we're going to do it in red, y is less than or equal to x plus 3. So easy one to graph. I start up 3, go up 1, right 1. I notice it's a solid line. Okay, plug in 0, 0. 0 is less than or equal to 0 plus 3. 0 is less than or equal to 3. That is true. So I'm going to be shading down. Okay. The next one I did was, let's see, the one with the fractions. Y is, greater, what was it? Greater than or equal to 2/7 x minus 4/7. Okay. 4/7 is about 1/2, so it's going to be right here in the middle. And now I'm going to go up 2, 1, 2, and then I'm going to go over 7. 1, 2, 3, 4, 5, 6, 7. It's going to be there. We'll notice again it's a solid line. And that was a terrible line. I hope you did better than I did. Good thing I'm not in Mr. Rodney's art class. So if I plug in 0, 0, 0 is greater than or equal to negative 4/7. 0 is bigger than anything that's negative. So this is true also, which means this I'm shading up. Okay? Now I have one more equation to do. This one's going to be up here in green. And I have 3x plus 2y is less than, already solved it, sorry. We don't need to do that again. We have y is less than or equal to negative 3 halves x plus 3. Okay, so I'm up 3, which means I'm at this dot again, down 3 over 2. I'm here, it's a solid line. And I got to rush here so I can make the time. I know this is long. Plug in 0, 0. I get 0 is less than 3, which is true. So I'm shading 0, 0 side. And we can see we're in between the red and the blue lines. Red's going down, blue's going up. And we're to the left of the green line. So our shading goes right in here. Okay? Sorry I had to rush through that at the end there. But that's solving systems of inequalities. If you pick any point in this shaded area, plug it into all 3 equations, it's going to make them true. Okay? So I hope you enjoyed Chapter 6. We'll be starting the tests shortly after this. So good luck, and we'll see you next chapter. Bye.